Good morning, class. This is your math teacher, Miss Corpus. And for our today's lesson, we are going to be moving on from graphing quadratic equations to solving one. So throughout this course, we've been trying to solve equations either through graphing or factoring. But what if we have some type of polynomial, such as this one? And my question is, can you solve this trinomial just by factoring? Well, after watching everyone trying to factor this polynomial, we have all concluded that we cannot factor this using the old method or the old way, like how we used to. But this does not mean that we cannot solve this anymore, or we should just give up. And for that reason, I am going to introduce to you a new method of solving quadratic equations, and this is going to be completing the square. Okay, so one of the ways that we solve quadratic equations using this method is when we have algebra tiles. So for our first example, we have x squared plus 4x plus 7. And the way that I use this algebra tiles is I let one huge square as our x squared. A long rectangle represents a positive x. Well, a green one is a positive x, and the red one is a negative x. And then this one little tiny square is positive 1 for blue and negative 1 for purple. So the way that I set up my algebra tiles is I just try to form a square. So I have my x squared plus 4x and plus 7. So I have 1, 2, 3, 4, 5, 6, 7 blue squares. And the way that I set this up is I look at the side of this square, and one of the side is x plus 2, and also another x plus 2. Now, since this is a quadratic equation, that means that it represents the area of a square. And the area of a square is basically just this one of the sides of it and squaring that. So it's s squared. And we also know that one of the sides of the squared, or this particular squared, is x plus 2 squared. So our new equation is x plus 2 squared. However, if you notice, we have 3 additional little squares here. And so the way that we complete the square is we do the original number of squares minus the number of squares that we actually needed to complete this square. So our original number of squares is 7 because we have plus 7 on our original equation. Minus, well, the only squares that we needed were 4 little squares. So you have 7 minus 4, which is equals to basically 3. And so we just add 3 onto our equation, our new equation. So now we have transformed our original equation into a new one by completing the square. Now that actually reminds us with our a different form of quadratic equations that we have discussed before or earlier in our unit lesson for quadratic equations. And that reminds us with the vertex form of the quadratic equations. Which is y equals a times x minus h squared plus k, where our a here is 1, our h is -2, and our k is actually just 3. Any lingering questions? If not, we can move on to the next one. So for our next example, we're solving another equation, and this time it's x squared minus 8x minus 9 equals 0. And again, we're going to solve this by completing the square. And for now, we're using algebra tiles. Here, I already have my x squared square. And so now, since our middle term is a negative number, and so we need 8 red rectangles. And I'm just going to rearrange them. So as you can see, we have an incomplete square where some of those little purple squares are missing. And we have, again, to recap, we have x squared, we have negative 8x, and we have negative 9. And so since we are missing some purple squares, we have to fill it out. Just to make note, you have, for each rows, you have 1, 2, 3, 4, 4 little squares, and that means that we're missing 2 more rows with 4 little squares. And so from there we could actually try to complete that, and I will be back with the completed square. And here it is. Since we have completed the square in the physical sense, so now since one of the sides is x, and we have 4 purple squares that stands for negative numbers, so we have x minus 4. The same thing with one of the sides, so we have x minus 4 since we have 4 red rectangles. And so again, when we're writing it down as an equation, we're going to rewrite the area of the square. So this is going to be s squared. And since one of our sides is just x minus 4, we have x minus 4 squared. And so we have partially set up that equation. And since we have negative 9 as our constant term, so in this rectangles or the squares, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 little squares. But then since we want to complete the setup, we had an additional 1, 2, 3, 4, 5, 6, 7. So when we're creating a formula for that, again, we have the original number of the squares, which is, again, it's negative 9. And we have minus the number of squares needed, which we had negative or minus 16, since we have 16 little cubes here. And then so negative 9 minus 16 will give us negative 25. So we're going to put that as our last term. And now we have turned this original equation into a vertex form. And so it's much easier to solve for this. Looking back to solving the quadratic equations by factoring, notice that we usually have two separate solutions for this. And so the same for this particular equation. We wanted to solve for x, and that means that we need to isolate the x by itself, or in simpler terms, we wanted to leave the x by itself. And so the first step that we could do is the negative 25 here. Now again, the opposite of subtraction is just adding. So we're doing the opposite of minus, and we're adding 25 on both sides. So we have x minus 4 squared. Again, these two cancels out, and so we have 0 plus 25, which is 25. And if you remember from our bell ringer that the square root and the square are actually opposite, they're opposite in terms of trying to cancel out. And so since we wanted to get rid of the square here, we wanted to do a square root of both sides. So we're taking the square root. And so the square root and the square here, they actually cancel out. And so we have, or what we're left is x minus 4 equals, now again, if we're taking the square root of any positive real number, we're gonna have two answers, the positive and the negative counterpart for that. And so we have plus or minus 5. And if we wanted to write it as two separate equation, you're gonna have x minus 4 equals positive 5, or just 5, and x minus 4 equals -5. Now it's much easier to solve for x, and we're going to do this twice. So for the first equation, you have x minus 4 equals 5. And so again, we wanted to move the -4 to the other side by doing the opposite. So we're going to add 4. So you have x equals 9. Now we're going to solve the other equation here. So we have x minus 4 equals -5. And so here it is, our solutions to this equation, which are x equals +9 and x equals -1. So before we move on to our additional practice, just want to make a quick note. So after you have found your solutions, it's much better to check them and see if they're correct by plugging in each of them back into your original equation and see if the left side matches the right side. Any lingering questions? And so with that, we're going to do our additional exercises or practice by doing completing the square and solving for x using these tiles with your partner. I already designated each pair with the provided worksheets, and you're going to do that with your partner or with the help of your partner. You're going to help each other and see what's going to be your answers for each of these equations.